This is an Algebra 1 lesson on growth and decay. We're going to learn how to deal with them as a function and how to write the equation for the function. First off, let's remember back to linear equations, how they worked. You'll recall if you put in the value of x, you can find the value of y. So we put it in. Let's say 3 times negative 1, x is negative 1. 3 times negative 1 is negative 3, plus 1 is negative 2. Do those for each one of these. Make sure you're remembering that this is the case, but here's what you come up with. As we look at that, we remember back from our previous lessons in linear functions that we could look and see that each time it's adding 3. That's the pattern. At the same time that we're adding 3 to the output, we're also adding 1 to each of the inputs. We can see pretty quickly then that this is the rise, this is the run, and that rise over run gives us 3 over 1, or that our slope is 3. Remember recall the formula y equals mx plus b. The slope here is 3. The y-intercept is 1. Let's remind ourselves that when we look at this, when x is 0, y is 1. That is the y-intercept. We'll be transferring that concept over. Okay, let's look at how it works here with a simple exponential function. Okay, we have now here y equals 3 to the negative 1. What does that mean? Remember, this does not mean a negative number. It means reciprocal. Okay, so that would be y equals 1 over 3 to the 1. It's the reciprocal. The exponent stays the same, except now it's positive. You know, the cut to the chase on it is, if it's in the numerator, it goes to the denominator. If it's the denominator, it goes to the numerator and loses the negative sign. So what we have here is that 3 to the x is 3 to the, and where x is negative 1 is 1/3. It is not a negative number. The negative exponent, recall, does not mean a negative number. It means reciprocal. Same here with 3 to the negative 2. When x is negative 2, we'll have y equals 1 over 3 squared, which is 1/9. Okay. Let's look at some more patterns. Okay. Start with this one. Now we're going to multiply by 5. Let's start with the initial. Oh, I forgot to do that on this back here. I forgot to say the other thing. I am so sorry. Let me go back to that and say right here. Let's look at how we get from one to another. And with the added 3 each time. But what do we do here? It's easier here. It's multiply. You can see it's getting big fast. It's going to be multiply, not add. You notice times 3. 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27. Well, is that true back here? If I'm going backwards, it would be divided by 3 forwards. 1/3 times 3 is 1. Yeah, that's right. And 1/9 times 3 is 1/3. Yeah, so it works. So, well, now why does that make sense? Let's think about that. What does an exponent mean? Okay, an exponent just means lazy person, lazy mathematician. I am like tired of writing 3's. So I just say how many times I'm going to write it. The exponent is how many times I've written it. That's what we've done here. Okay. So when the exponent is 3, we've written it 3 times. And so on. That's why with the multiplication, you're going to get an exponent, how many times you multiplied. Back here in the ones that we've done a long time ago, with addition, you'll add on the y, add on the x, and that gives you a nice straight line with a slope that can be calculated there. Okay, now back to this one. Here we're adding in the extra thing that out in front of the base of the exponent is a number that's multiplied. Again, 0 is the easiest. Let's do 0.